Okay, today we're going to solve systems of equations by substitution. In this slide I just listed the steps for solving by substitution, which will become clearer when I show you some examples. Okay, so the first thing you need to do is get a variable by itself, and sometimes this is already done. You already have y or x by itself. Then you need to take what you got for your y or x and put it into the other equation, the equation you haven't used yet. So you're going to put it in the second equation. Okay, you should only have one variable once you've done that. If you still have two variables, then you messed up somewhere. Okay, then you're going to solve your equation for the one remaining variable. Once you've got that variable, you get x equals 7 or x equals 2, then you're going to take that and plug it in for x into one of the original equations so that you can find the second variable. And then most important of all, you're going to check your solution. Okay, so here's our first example. Y equals negative 4x plus 8 and y equals x plus 7. As you can see, I have y by itself in both equations. So since I have that, I'm going to take x plus 7 and I'm going to replace it for y in the other equation, the equation I have not touched yet. So I'm going to have x plus 7 equals negative 4x plus 8. And then I'm going to go ahead, and as you can see now, look, I only have one variable. So it's only x. So now I'm going to go ahead and get x by itself. I'm just going to solve this equation. You guys know how to do this. You've been doing this forever. So I'm going to add 4x to both sides. And I get 5x plus 7 equals 8. And then I'm going to subtract 7. So I get 5x equals 1. And then divide by 5. And I get x equals 1/5. Now once you have your x, you're going to take what x equals. Okay, that was my daughter on the phone, but you're going to take what x equals and you're going to substitute it back in for one of your x's in one of your equations. So we're doing lots of substitution. That's why this method is called substitution. So you're going to take x equals 1/5 and you're going to replace it. I'm replacing it in the second equation because it's a nice easy equation. I'm going to plug in 1/5 for x. So then I have y equals 7 and 1/5. Your answer then is 1/5 and 7 and 1/5. Now this would have been difficult to graph, as you can see, because it would be hard to see with it they crossed at 1/5 with for graphing this by hand. So this would have been a hard equation to graph. I cannot forget my last most important step, and that is to check my solution. So here is what the check looks like. You're going to take 1/5 and plug it in for x, and 7 and 1/5 and plug it in for y, and make sure that you get two true equations. So I have 7 and 1/5 equals negative 4 times 1/5 plus 8. So 7 and 1/5. Negative 4 times 1/5 is negative 4/5 plus 8. And 7 and 1/5 equals 7 and 1/5. So this is true. That's my first check, and then you have to check it in the second equation. So for the second equation, I'll use pink, and we're going to have 7 and 1/5 equals 1/5 plus 7, which is also true. So there is our check. You have to make it has to be true in both equations. In our next example, we have 3y plus 2x equals 4 and negative 6x plus y equals negative 7. This time we don't have anything by itself, but we have a very good variable to choose to get by itself. And we want to get this y by itself because if you notice the coefficient on it is 1, so we wouldn't have to divide by anything. So that's the equation I'm going to take, and I'm going to get y by itself. So I'm going to add 6x, and I have y equals 6x minus 7, or negative 7 plus 6x, if you like that better. Now I'm going to take what I got for y, and I'm going to plug it into the other equation, the equation I haven't used yet, and I'm replacing y with it because y equals it. So it's going up in for y. And when you do this, you want to replace, when you replace y, you want to put it in parentheses so you remember to distribute your coefficient. Now when you look, I have one equation and I only have one variable, and that's what you want. Remember, if you have two variables still, something went wrong and you need to start over. So we're going to do the distributive property. We get 18x minus 21 plus 2x equals 4. And then I combine my like terms. So I have 20x minus 21 equals 4. And then add 21. So I have 20x equals 25 divided by 20. Put that in your calculator. You can simplify, but 5 goes into both 25 and 20, so you get 5 over 4. And I'm going to leave it improper like that. Now, I know it seems like we've done so much work already, but we're still not done because we have to figure out what y equals. And in the first slide, I told you to take what x equals and plug it into one of your original equations. But I'm going to give you a little trick here. I think if you take x and you plug it in right here, because y is already by itself, it's a little bit easier. So you're going to have y equals 6 times 5/4 minus 7. The 6 and the 4 can cancel. So we would have a 3 and a 2, and we would get 15 halves minus 7. And then y equals, if you throw that in your calculator or you get a common denominator, you would have 15 halves minus 14 halves equals 1/2. So the solution to this system of equations is 5/4, 1/2. I don't have a lot of room to check this, so I'm going to check it on the next slide. Okay, so I've rewritten my original equation and I've taken my answer and I've changed it to decimals so that I can just plug it into my equation really quick. So I'm going to take these two numbers and plug them in for x and y. And you need to check it in both equations. So you're going to have 3 times 0.5 plus 2 times 1.25 equals 4. 3 times 0.5 is 1.5. 2 times 1.25 is 2.5. And if I add those together, I do get 4. So that's true. But I also have to check it in my second equation. So in my second equation, it's going to be negative 6 times 1.25 plus 0.5 equals negative 7. Negative 6 times 1.25 is negative 7.5 plus 0.5 equals negative 7, which is true. So we've now checked our solution.